Okay. So last time we worked with IO classes, and now we will start working with the NIO classes, which is non-blocking IO, because it works better with threads. So in order for you to work with NIO package classes, you have to import the java.nio.file. So you learn about the hierarchy of this, that there is a folder Java, which has a subfolder NIO, which has a subfolder file. And all those files or classes you need are inside the file package. So that's what basically that is. NIO in java.nio stands for new input output, because its classes are new. Well, in some of the articles, it says non-blocking. So we have two different opinions on that probably. To create a path, for example, so you will see a totally different set of classes in the NIO package. So we use a class called path, which calls getPath method to load the file that you want to read and talk to. So that's NIO. NIO is slightly different than the IO approach. Similarly, if you want to create a path yourself, you can see the second example, c:/fs.getSeparator will bring in a slash. Okay. Why would you want to do that? In case if your operating system does not use a slash, then you can take that approach. You're giving it to your operating system, whatever it is that you think give me that. And also, you would want to use 2 slashes, because single slash is escape sequence character. Another way to create a path is to use the paths class with an S. The paths class is a helper class that eliminates the need to create file system object. The paths class get method calls the get path for you, so you don't have to create a file system object and then call it that way. So do you guys know the difference between absolute and relative path?
I don't.
Absolute goes all the way from root, while relative is relative from the folder you're in.
Right, exactly. So absolute path is the complete path from the root, like a drive letter, all the way through to where you are. Like here, you can see the example. This is the absolute path. Relative path is based on where you are. For example, if you're sitting in a folder and you want to go to another folder in the same root, you can say, well, from where I am, go to chapter 13 folder, and from there, go to samplefile.txt. So it is contextual to where you are. When you're hosting your contents on a website, which of the two approaches should you take when you're building your site? Relative or absolute? You must have learned about that in the internet programming class.
Relative.
Relative, right? And why do you want to do that? Why do you want to build the paths in your pages in a website relative, not absolute?
Would it be because if you're on, let's say, the home page and you want to go to a different page, like on the menu, you know, it wouldn't need to start over necessarily, but can jump kind of from where you are to the next page?
That's not the main reason. The main reason of creating a relative path versus absolute path is for the sake of deployment. But when you deploy it on a web server, if you have created absolute paths, you're telling the web server to look for that file on its C drive, for example, and it won't be able to find it because your entire project may be sitting on any drive letter that the web server chooses. So none of your pages will load, none of the images will show if you build your absolute path website. So always build a relative path website So when you deploy your folder on the web server, it builds the rest of the path relative to that folder. Retrieving information about a path. So you can use a toString method, which returns the string representation of the path, or getFileName method, which returns the name of the file, or getNameCount, which returns the number of elements in the file. For example, if your path is C:\myfolder/subfolder/, so all these slashes are considered to be different names in the path. So it returns the total number of the total count of that. And getName will returns the name in the position of the path specified by the integer parameter. So get me name at this position, and so on and so forth. Here is your example to look at. As you can see in this example, the author used absolute path, not the relative path. And in this absolute path, she's trying to look for data.txt. And after she does that, she's asking the file path to give me the count, the name count. So the name count here is 3. Okay. Why the name count is 3? Because Java is 1, chapter.13 is another, and data.txt is the third one. So there are 3 items in the count. And then she's displaying the file path.toString. She's converting that to the string. She's displaying just the file name part of it. Then she's displaying there are 3 elements in the file path. And then she's going through each of the elements one by one, because file path.getName, she's calling the getName method and going index 0, index 1, index 2. So index 0 is Java. It doesn't count the root letter. Index 2 will be, index 1 will be this, and index 2 will be data. Here is another example where she's asking the user to enter a file name, and she will look for that file on the path, and she will going to convert that into an absolute path. And then she will display the absolute path. So if the file is found, the absolute path will be displayed. If it is not found, then it will not display anything. Similarly, you have certain constants that come from the access mode, or rather it's, let me put it this way. Did you notice one thing different between this import and the other imports that you have done in the past?
It has static.
Right. So when you do a static import on a certain class, and it's not part of your hierarchy, it's not part of your basic package, you can after that access things inside that class without reference. Like if there is a constant declared inside access mode, you'll be able to access that. Like for example, there's a constant read declared inside access mode. There is a constant write and execute. They are declared inside access mode. So you need static access to access mode to be able to use these things. So notice here in the try block, we are literally typing read and execute. And in the program, you will not find any declaration for read and execute. They're being directly referenced from access mode, which is imported static. So that's what the static imports are for. So here in this example, we are setting the file path, which is the path class object, and we are opening it for reading and executing purpose. And then we can display the message if file can be read and executed, if this line didn't fail. If this line failed, then we will go to the catch, which will display the following file cannot be read, or whatever is the error message. Did we had somebody else joined? Because the list grew a little bit. Still missing people? Or whoever joined us and wants to tell me. That's a different deal. Who joined? Come on. Really? You don't want to tell me? You want me to figure it out? Okay. I don't know if you can hear me or not. Is it
Was it
me?
Francisco?
I want Francisco to speak. I don't know why Francisco is not speaking. I don't know if you can hear me or not. I hope you can hear me. Okay. So guys, let's open Eclipse and let's start working with some of these examples. So this is what we did last time here. So let me close this. You know what? I will just use the same project because we're still doing chapter 13 and we created chapters 12 and 13 project last time. I will just use that same project. Do you guys have the project?
Yep.
Okay, cool. So let's create a new class here and we're going to call this one file NIO demo with the public static void main. So we use path class to create an object of file type, and we use paths.get to talk to the text file. Paths.get, let me use the demo.txt that we created last week. Okay, so we can just do that, use that. What? It is right there. Oh, my bad. I should not have used the word new. Paths.get, yes, yes. Because paths.get return an object of path type. I am planning on using this class, basic file attributes, in our example. So what basic file attributes can do, it could read some of the basic attributes like what time the file was created, when was it last modified, what is the size of the file. These basic attributes, the basic file attributes class object can read on the file object. Also on page number 644, it talks about if you want to delete a file, then you can call the delete method on the files class, which is a different class from a paths class, and provide the file path, which is an object of path type, and it will just delete the file. So that's what, okay, so we'll be using basic file attributes. Hold on a second.
What did you do to get your basic file attribute to not be an error?
I on the right hand side, I wrote new.
Ah, I see.
For those of you who are done with this example, did you also understand the example as to what's going on here?
What is the 0? So what is it comparing it to?
Well, when we are comparing the time value for the first time, which is the value returned by the creation time method. So creation time method returns the creation time that the file was created. And then this time is stored in the file time object called time1. Then similarly, the creation time is another attribute that we called for the file 2, which gets stored in time2. Then we are comparing the two objects, the value stored in time1, compare that with the value stored in time2. Now, compare to is a built-in function of the file time class, which overrides the function from the object class. It lets you compare two file time objects. So when the two file time objects are compared, if the first file time object's time is compared to the second file time object and the value is a negative value, that means the first object was created before the second object. So that's where we're checking if the value is less than 0. If the value is greater than 0 means that the time one was created after time 2. And if they're the same values, then they were created at the same time.
Okay.
Anybody else has any question before we move on? Or is there anybody still coding? Like we have Christian, Aiden, Jack.
I'm still coding and I'm not entirely sure what's going on.
So where did you join the class from the beginning, right? Or no?
Yeah.
Yeah, okay. So I mean, like, where is it that you don't know what's going on?
So I'm gonna try to walk through it. We've got the path. So we're trying to get to the demo files.
Right.
And then we're gonna try to read the attributes.
Yep, we're
of the
reading
file.
the file properties, like, when was it created, when was it last modified, what
Okay.
is the read operation, the write operation, all the properties that are related to a file. So that gets stored in an attribute called attr1. So we have a special class in Java NIO package just to store the file attributes. So we are storing the attributes of file 1 in attr1.
And then we're
we're
comparing them.
And then we're storing all the attributes of file 2 in attr2. And from the list of attribute, we are extracting the creation time, and we are storing that in the file time object. And we're doing that for each of the two. And yes, and then we are comparing their times to figure out which one was created before or after.
Okay. All right, it makes sense now.
Mhm.
I'm still coding though.
Yeah, that's fine. Let me know when you're done. How about Jack and Aiden? You guys are also coding? Oh, Jack is done. Oh, Jack is done. Okay. Aiden, I think, might still be coding. Yeah, I know. I mean, Macs are always a little bit different when it comes to programming. I wonder how your GUI will work on Mac, because sometimes Mac does things slightly differently. So let's hope for the best.
So I'm getting an error in mine. Basic file attribute, files, read attributes, all that stuff is underlined with red.
Did you import?
I did. I have 4 imports currently.
Okay, and basic file attributes is one of the imports.
Yes.
Okay. Did you check the right-hand side to see if it matches my right-hand side?
Yeah, I don't see anything. Oh, wait, hold on. I did find an error, but that didn't solve the problem.
Okay, try saving the file after you fix the error.
Okay,
Still have the error?
yeah.
Okay, how about you share your screen?
Okay.
Oh, you're missing semicolons on both lines. You don't have semicolons on line 13. Towards the end of the line, there should be a semicolon, right?
Oh, okay.
Save the changes. Okay, now. Okay, it's actually basic file attributes with an S.
Oh.
Okay. And then it is not fail time, it's pass time. No, it is file time, not fail time. Come on. Be positive, man. It's more than a blood group. Cool. Okay, now run it. Let's see. Save the changes again.
I didn't finish with the
Oh, you've not finished. Okay, I'll share the code.
time.
Do you know why Macs are always old, even if you buy a brand new one?
Nah, but I'm sure you got a funny joke about it.
Right, I do.
Well, I mean, the iPhone is just the same model. All they do is just do a Photoshop effect.
No, it's always an old one whenever they give you a brand new one, because the apple is already eaten and somebody takes the first bite and that's not you. See?
But
Is that Snow White? Or maybe are they trying to tell you that it's heavenly machine?
On a roll.
So as you can see in this example, that when we do things through the NIO package, things are very different as compared to doing things with the IO package. The classes are entirely different. The way you do things are different. It's a totally different architecture. Aiden, did it get fixed? The mouse error?
So I'm having an error, but I don't know what it is.
You're having error, but you don't know what it is.
It says error demo txt.
Oh, probably you don't have, okay, show me your screen. Show me your code. Right, because you don't have the demo.txt. Is that what it is? No, you do. No, leave it there, leave it there. Leave it there. Okay. Oh, why did you move it? You should have copy pasted because now your other project will not work. So copy them. You have to do it one by one. Or yeah, does it let you? Yeah, okay, right click, copy. No, don't drag, don't drag. Right click, copy. And right click on week 12 and paste. Use, yeah, okay, cool. Okay. Let's see. It's saying demo.txt. Can you close that file nio demo.java tab? Yeah, just close it. Okay. Double click to open it again. Run it again.
So one thing is the second file time, it should be ATTR2.
Oh, you're right. Line 18. It should be line 18. Yeah. But it is not recognizing demo.txt is what
Huh.
I don't get it. Okay. Can you double click on demo.txt? Okay. Hold on a second. Okay, close that. Okay, can you select lines 16 through 25? Click the source menu and choose toggle comment. Okay, now save the changes and run it. Okay, so that line is failing, line 15. Okay, can you comment out line 15? And save the changes and run it. Yeah, click. Yeah, okay, that's fine. Okay, that's fine. Okay, select uncommon line 17. Okay, now run it. It doesn't see any of the two files. Okay, file one, paths.get demo.txt. Can you right click on your project, week 13 and 14 project, and refresh? Now run your program. No, it still doesn't see. Okay, when you hover over path file one, what is that warning? Oh, okay, okay, no, forget about it. It's just a warning that's not used. Go to line number 28. Go towards the end of line 28 and hit enter. And on the next line, type E dot print. Okay, double click on the very first one. Yeah, rerun it. Save the changes and run it again. Okay, hold on, just let me see. Scroll up in the error log. No such file exception. So it's not able to see the file to see if it even exists. Okay, right click on the demo.txt and go to properties. Properties towards the bottom. Okay. Can you copy everything in the location? Right click on the selected text and copy. Okay, now hit cancel. Okay. Now go down to line 12 in the double quotes before the demo 2. Before the, okay, yeah, click there. Inside the double quotes before the word demo 2. Before the word demo 2. Okay, delete the word demo. Only delete the word demo. No, only delete the word demo. Okay. And paste whatever you copied. Okay. Now get rid of .txt. No, not that one. The one to the, okay. Now put demo 2. Get rid of the 2 in the end. Okay, put demo 2. Okay. Now save the changes and run. Okay, that works. Copy lines, yeah, go to line number 11 and paste within the double quotes. And get rid of .txt. Okay, now uncomment all these lines. So select lines 15 through 25. And source toggle. And click toggle again. Source. Oh, hold on a second. Hold it. Go back to your code and comment line 17. Yeah, now select and then toggle. Okay, now run it. Okay. For some reason, it wants absolute path from you. Maybe it's a version difference in Eclipse. Eclipse is forcing you to do that. But anyway, we got it fixed. Jack, you still coding or you're good? Okay.
Thank you.
Mm-hmm. Okay, so now we will save this example as file NIO demo 2. So Christian, for all these examples, you maintain your complete path. Okay. So the file I'm using is demo3.txt. I just got rid of everything in the try block. We'll fix the error on line 18 in just a minute. So what I would like you to do is paste what I just did on, like type what I just gave you on line number 8. We are importing a static class called standard open option. And that's where I have my constant create that I'm using on line number 18. You know what? I gotta use buffered output stream.
Did you delete the create import? The static import?
Oh no, it just moved up. Automatically Eclipse pushes it to the top.
Oh, okay.
Do you guys see something strange on line 18?
All capitals?
No, that's a constant. Line 18.
Oh, okay.
Yeah, that's a constant. That's not strange. Inside the parentheses of buffered output stream, we are calling a method called new output stream of files class because it's a static method. That's why we are calling it by the file name. If it was a non-static method, we would have called it by the object name. But we have a files class method new output stream, which takes 2 parameters. One is the path and the other one is the option. What do you want to do? I'm telling that I am creating a new file. Okay. So since I want to create a new file, I already have the demo3 created. I will change this to demo5. Okay. So change the file name to demo5 from demo3. Line number 18, what is different? That you generally don't do.
I'm not sure.
There's no space between the new and the output stream like we normally do.
No, spacing, wildcard characters are not important. What is the data type of output?
So output stream, and then it's initialized as a buffered output stream.
Right, so we are calling, the class name of the object is something else, but we are calling a constructor of a different class. How can we do that? How can you create an object of one type, but call a constructor of another type? And it's not even airing out. Yes, Jessica, you're saying something?
Sorry, my mic was having
Oh.
trouble. Is it because buffered output stream is like a child class of output stream?
Very good. This is the same example that we learned in chapter number 12, chapter 11 with about animal and dog. Do you guys remember that? That we created an object of animal type, but we were calling the constructor of dog type. This is that exact implementation here, that a parent class object can call a child class constructor. Okay, that's why first 12 chapters in the book, if you know them, you will understand everything that we will be doing in Java, because everything is based off that. Okay. So here you see the implementation of the idea that you learn in chapter number 11. Okay, now in the try block, I want to write the data to the file. So output dot write, and I would like to write the data, which is my byte array. And then I want to flush the data out of the memory. And then I want to close the stream. Now let's run this. And if it produces no output, that means you are fine. It went through, nothing was wrong. All you need to do is refresh your project, and you should now see demo5.txt in the list, just like last week. Refresh the project, and you will see the new file. And whenever you are done refreshing, double click on the demo5.txt and you will see the text Java programming, and that's the text that we are passing into the body of the file. Again, give me a green check whenever you guys are done. Everybody is done except for,
So I'm having an error with mine.
me too. How can I fix my error? Christian,
I have no idea.
just kidding. Go ahead, share your screen. I'm pretty sure you checked the code line by line, right?
Yeah.
No, you did not. Hmm.
Because there used to be this here.
I will share my screen again.
Okay.
I want you to fix that line. Check my line 12 against yours. Why do you have 2 equals to on this line?
I have no idea why that's there.
You do need the complete path to the file. That's fine. But yeah. That should fix your problem though.
It didn't work.
Is the error gone from that line?
Okay, now it worked.
Did you refresh the project to see that you have demo5.txt created?
Let's see. Yeah, no, it's still, it's not there.
Okay, let's see what's going on then. Share your screen. Let's see what's going on. Okay, actually, okay, can you run it again, please? Okay, can you right click and refresh?
Your path is pointing to demo 3.
Oh, thank you. Yes, 5, right.
And then nothing, no, it's not going to make another one because demo 3 already exists.
Right, exactly. So that's why demo 5. Yeah, we wanted to create a new one. That's why we changed it to 5. Okay.
Okay.
That takes care of your error. Okay, now it's time to read the information back. So let's save this one as number 3. We will keep the file path exactly the same. And I want to read everything back. So instead of output, I will need an input stream. And I do not need lines 13 and 14. I'll change my object name to input. And likewise, I'll make some other changes, like instead of buffered input stream, I'll use the output stream, I'll use the buffered input stream. Files.new input stream. Okay. And I don't need to create. So far, we did this. Now it's time to read the data. So we'll be declaring a string object to read the data from the file. input dot read. For a sec. No, hold on a second. Hold on a second. I gotta use a slightly different class here. I would have to do it to, okay, just 1 second. Let me do directly with buffered input stream. And then let me do input dot. Or, you know what? Let me try with this approach. Input equals to files.new input stream. So I'm reading these here, okay. And now let me use a buffered reader class. And instead of buffered input stream, let me use buffered reader. There we go. So on line number 17, you notice that in the buffered reader constructor, I'm creating an unknown or unnamed object of input stream reader type, because buffered reader cannot directly read from the input stream. So I took my input stream object, which was input, converted that into a input stream reader object, and then I gave the input stream reader object to the buffered reader. So in the file handling, you may see these kind of syntaxes. They're quite common. When you want to read in a certain way and your file is in a certain way, you got to find the intermediate classes which allow you to convert from one form to the other. Okay, everybody got this? Oh, Jack, except for Jack. Okay, or Jack, your check mark disappeared. Okay. Now, our next step would be to read multiple lines because we're only reading one line in this example. So let's save this one as number4.java. File NIO demo4.java. Now, instead of reading demo5, let me read demo because demo has multiple lines. So that's why I'm changing my file to demo. We will still be converting it into a new input stream object. From there, we'll be converting it into an input stream reader. From there, we'll be converting it into a buffered reader. But what we need to do different is right here, right here. I'll be starting a while loop in which I want to make sure if the string is not equals to null, then display the current value and then fetch the next one. That's it. That's the only change you got to make to read multiple lines.
That should output everything from all of the demo text files.
No, only the
Or just the first?
demo.txt.
Oh, okay, yeah.
Yeah. Okay, can you open demo.txt text file? And I want you to misspell the word. I've changed your first line to say Sam was here, and I'm purposely misspelling the word here. And then save the changes. And close the tab and rerun demo4, and you should now be able to see that whatever change you made is displayed. And let me remove this output colon so that we can see directly the contents without any additions. Oh. Yeah, let me know when you guys are done with this one.
What changes did we make again?
I just went to the demo.txt, and on my first line, I had Sam was here, so I misspelled the word here to H-E-A-R instead of H-E-R-E. Saved the changes, closed it, and ran it again to see the change. Okay, that's fine. And I think one of the jacks is still coding too. So I'm talking with Jack Lear. So far, all the examples that we did are to do with sequential access. In my next example, whenever everybody's done, I want to work with random access. Random access allow you to jump X number of byte and go to the location wherever you want to go and then make the changes. That's one of the basic benefit of using a random access because it's faster. So what I would want to do in my next example is that I want to change that word that I misspelled, H-E-A-R here. I want to change it back to H-E-R-E here, the proper here, okay? Now that everybody's done, let's save it as demo 5. Okay. And on the very first line, and Christian, you leave the full path there. just in case, if half
Yeah,
path
okay.
doesn't works, right?
I will.
Okay. Oh, my bad. I should have moved this before the main, not in the main. Yeah, because I want to create it global to all the methods inside. Okay. We'll come back to main to finish main. But for now, leave the main skeleton like this. We'll create a function to write data to the file, which will need the position and the data to be written out. Now, the moment I say I'm typing towards the end of line number 20, what does that mean? That means that this method does not have any local try catch block. In case of any errors, redirect them to its caller. So let's say if I'm making a call from main. So notice the errors disappear from line number 9, because now line number 7 is telling line number 9 that I'm calling a method which, if it has any problems, will redirect the errors to me. So you will handle the errors. Okay, so now let's write the code inside, which will be about random access files. I told you, random access file equals to new random access file. So we are opening the file that we declared on line number 3, and we're opening it for read write. So we'll use the method seek that will jump to position byte in the file. Okay, so So the reason I wrote what I wrote in the comments on line 24 is to help you understand why I'm passing number 8 to write to file method. Because what I'm asking, the file object, which is tapping into the file demo.txt, that I want you to read the 8th byte. I want you to jump to the 8th byte. So 0, 1, 2, 3, 4, 5, 6, 7. 7 is up to that space before the here, the misspelled here. And then 8 will be the beginning of that. So I want it to jump over here. And that's what I'm seeking for. The seek method will help me go to that place. Once I am at that location, then I will start writing the X number of bytes, which is the data here that I'm passing. And that's what's get converted into from a string to bytes before it's written out to the file.
So if you wanted to go down to the line where it says Jason went home, if you wanted to change something down there, would you just kind of keep counting the bytes, I guess, just to know what number that is, or would it be a whole new line?
I'll have you look at an example in the book for that.
Okay,
We'll be looking at another example.
thanks.
Random access files, yes, they do work on calculations. The biggest problem with demo.txt is that it's not a good candidate to explain that. The reason is because random access files in Java require all lines to be of the same size, and you should know the size of the line, and then it needs some kind of a multiplier to multiply to jump to those many bytes.
Okay, gotcha. That makes sense.
So after saving, when you run this one, there'll be no output, but let's refresh the project and let's make sure that, oops, not this one. See, the word HEAR is now replaced with the word HERE. Oh, is everybody done with this one, or are these from the previous ones, these green checks?
I haven't finished yet.
Oh, okay.
So I'm having an error in random access file
On line number 16,
26.
line 26.
Or sorry, yeah, 16. I don't
Yeah.
wait, why are there 26 lines?
I don't know. Did you?
Okay.
Get rid of the other imports at the top that weren't needed.
Yeah, go to your source menu and hit organize imports. And that will get rid of any unneeded packages or classes.
Oh, fancy.
Okay, now it's saying input isn't used.
That must be the warning. So probably you might still have input use like listed somewhere because I removed that. So why don't you go over my code with your code line by line? And that, you know, you might have missed something. You might have forgotten to remove something.
Mm. Okay, I did forget to remove something. However, I'm still having this other issue. I'm gonna walk through it though, real
Mhm.
quick.
Did you find it?
I forgot the word new.
Oh,
After file equals new random access file. Oh, wow, it worked.
okay, cool. Anybody still working on the right to file one? Okay, now let's create another method then. Private static. It'll be a byte array, read from file. So we want to read some random position, and we want to read the random number of bytes. And again, if anything goes wrong, we want to throw an IO exception, which will again go back to the caller. So I'm copying line 16, but this time I will be opening file for read only. I will be seeking to go for the position that gets passed as a parameter. So I'm using the positions value to go to that certain position in the file, then start reading from that location into the bytes array. So whatever size I pass, that's how many bytes I'm interested in reading. All of those bytes will be transferred over into the bytes array, and then I'm returning the bytes array to the caller. So here, inside the main, I'll convert the returned value into a string. Read from file. So it'll read space was space H. So I'm reading 6 bytes starting from the third position. So third means fourth because it starts with 0. So Sam, or 0, 1, 2, 3 is the space, and then reads the next 6. Space, was, space, and H. So notice what I did here on line number 9, I changed them to 10, 6. So what I'm saying is I want to start reading from 10th place, right? So it starts reading RE period, right? So it just goes and reads RE in a period. So that's 3, right? Then it reads the letter J on the next line. Why does it not read JAS? Why does it only read J? Because I need 6 bytes, right? Why does it only read 4?
Because /n is 2 bytes.
Very good. And why is /n 2 bytes? Does anybody knows why /n is taking 2 bytes as opposed to taking 1 byte?
Is it, I mean, is it as simple as 1 for slash and 1 for n?
No.
Okay, I didn't think so, but I was gonna take a crack at it anyway.
No. why enter key is taking 2 bytes. You have to understand this only if you understand how typewriters worked in the good old days.
Is it one? I want to say it's like one for down and one for starting a new line, like one for down, one for over.
Yes, yes, we used to call that line feed and carriage return. Okay, so line feed and carriage return. So you feed a line, and that's 1 byte, and then you hit the dang to go to make the cursor go to the beginning. So carriage return. So yes, /R and /F. You know, back in 1970s, that's how we used to code /N as /R/F. /F/R. You got to feed the line and hit the return. Yeah. /F/R. Back in 70s, from my times.
Is that only because you went back in time to the 70s?
Thank you for making me feel young.
Oh, I was just calling you Barry Allen again. But you know, if the compliments help my grade, I'll keep them coming.
You know, when I was part of the workforce back in 1970s, that doesn't sound right. Yeah, no. Okay, let me know when you guys are done.
We can't hear you if you're talking to us.
Oh, can you hear me now?
Yep.
Okay, okay. So I am now going to the random access data section in the book. Let's see. Here you go. Okay, this is what I wanted to show you guys earlier on. And Jessica, this is what I was talking about, that you have to have something like this for the random access stuff to work, literally. So if you notice, all the records are exactly the same size. So what the author did in this example is that she created a structure, fixed size structure. And after she created that fixed size structure, she created a line separator for new line. Okay, so it's a combination of a fixed structure and a line separator, which is a new line. And now in a loop, she's generating all these records, which are close to 1,000 records. And that's what basically the file looks like. Okay, so this is what I was talking about. So that's what basically it gets created. And then after that, once that all the records are exactly of the same size, so she carefully puts the data which fits perfectly in the letter length, in the record length. And then after she does that, because all the records are exactly of the same size, right? So then she gets the record size of this one record that she carefully put that matches the exact same length. And then she multiplied that by a number to jump those many records. So because employee number is 2, she wants to go to the beginning of the second record, and that's where she wants to insert it. Sorry, jump the 2 records, and that's where she wants to insert it. So that's where it gets inserted. So she's jumping 2 records because she multiplied 2 times the size of each record. So this is something, it's not very practical if you ask me to do random access this way. But that basically is the only way out that can be done.
Gotcha. Yeah, no, I don't think that'd be too practical, but yeah, it's good to know still.
Yeah. And then she wrote a code where she is, again, giving the same record length, and she's asking user to enter 999 to quit. And she's accepting the employee ID from the user, the rate from the user, and then she's setting it all up. Okay. And then she is setting it all up such that if you notice all her names, did you notice they're all 7 letters long?
Wow, that is
Right?
just something.
And then she wants to nicely fit in that spot. So yeah, practically speaking, I'm like, so they go in those little spots where they need to go. Anyway, so I would like you guys to go ahead and read this don't do it area, which is right past page number 676. If you hit next page, then read the chapter summary. Okay, so everybody get to read that. So now we will be moving on to chapter number 14, which is about the graphical user interface programming of Java. But in this graphical user interface programming of Java, you will need to apply all the concepts that you have learned in the past, and we will get to see those coming to live. So we will, however, look at it after the break. So let's take a break till 7:45. And then when we come back from the break, we'll start with chapter 14. And chapter 14 will be with us today as well as next week. And that will be our main focus. This will be the last chapter. We'll be looking at it in this course. So let's take a break here. And then I will see you guys at 7:45. As I told you guys before we went on break, that we will be looking at chapter number 14. And chapter number 14 is the graphical user interface programming of Java. Java, let me give you some historical background. In 1990s, originally when Java came about as a graphical user interface development programming language, it came up with an architecture that it called AWT. The reason you need to know about this architecture, because if you're learning about swing architecture, which is the focus for chapter 14, swing architecture is actually an offshoot of AWT. So you will still see some AWT classes, even though you're learning swing. Because swing improved on anything that AWT was lacking, but anything that AWT was okay with, it didn't do any improvement to that. So we use it as it is. So AWT is abstract window toolkit environment. The reason after 2-3 years of using AWT, Java developers decided to go to the swing route was because AWT was taking a lot of system resources. It was slow because it was reliant on the operating system. So Java was like, let me create my own environment that would run from VMware, as opposed to asking operating system to give me your look and feel, and then working with the operating system's built-in native objects. So Swing was introduced. That's why all the Swing classes, as you can see here in the bullet points, you will notice that you don't see a class called frame, you see a class called JFrame. You don't see a class called label, you see JLabel. You don't see a class called button, you see JButton. So any class that starts with an uppercase J, it's a Swing class. If you drop that uppercase J, that was the name of the AWT class. And when you're creating a Swing environment, your graphical user interface classes cannot be any of the AWT classes. Your support classes can be AWT, but not the main graphical user interface environment classes. So anytime you see the J next to a class name, it is an indicator that the older version of this class would have been without the letter J from the AWT environment. Does that make sense to you guys? Okay.
Yeah.
Now, when Java introduced the AWT environment, it created a package called java.awt. That was the name of the AWT package. When Swing was introduced, Swing is an extension of Java. So when Java 2 was introduced, Swing was introduced with Java 2. Swing was not there in Java 1. So what they did, they created a new package that starts with Java X. And you have used a Swing class JOption pane. And anytime we use JOption pane, it starts with an uppercase J because it's a Swing class. And you would see in your imports Java x.swing.jOptionPane. Okay. So when we do the graphical user interface programming in Java, we need to create a window like a form. So I will be using some C# terminologies just so that you guys can understand, but some of those terminologies may not apply to Java. So what you call in form in Swing, we call that frame or JFrame in Java. Okay, so we don't have the word form. So the window on which you put your graphical user interface items or objects is called JFrame. Now, JFrame can hold many objects, however, not on its core level. At its core level, it can only hold one object. So what we do is we introduce what we call layout managers. That's the fourth item in the list that you see here in the chapter. Layout managers allow frame to hold more than one items. So to the frame, it has a single layout manager. The frame thinks, oh, I'm still dealing with one object. But in reality, that layout manager is the one that deals with the other objects. There are different kinds of layout managers. Like if you want items to be arranged in as they come in, as they arrive, then you use flow layout. If you want items to be in a certain directions like east, west, north, south, then use border layout. You have grid layout if you want to nicely align them in a grid format. You have a grid bag layout. You have card layout. You have all these different kinds of layouts. The problem is, what if I run out of space in a layout? Or if I want to have some disharmony within the harmonized layout, so what I can do, I can nest a layout within a layout. So for example, I want my north area to have a flow layout. So what I will do is to the frame, I'll say, okay, I will give you the border layout, which is north, east, south, west, center. But in the north, I'll say north, I will give you another layout. And that layout will have the graphical user interface objects. Similarly, I can go down south and say, okay, south, you have another layout in you. Let's say card layout, and these are the components that are put in the card layout that you can show. But to that region, the layer closest to it would be another layout. So that's called nested layout. If you look at Eclipse environment is, if you notice, this is your west layout, okay? East layout, south layout. Okay, we don't have any north, but this is the center layout. So center layout is capable of absorbing all the areas that is missing. For example, if I delete, if I close outline, notice all this area is eaten up by center. That's exactly how the border layout works. Also, Java lets you add toolbars, lets you add menu bar. All of these things can be added to your frames. Okay, now frames are like forms. That's one kind of a window. The other kind of a window is called a dialog box, like jOptionPane, that it comes on top of an existing window, and until and unless you get rid of it, you can't really continue with your work. So creating a form or creating a frame with a graphical user interface is one thing. Organizing it is one thing, but actually the whole purpose of creating a graphical user interface environment is so that the user can interact with it. In order to make it interactable, we need what we call event listeners. Event listeners is what makes each one of the item respond back to the user's request. Now, for example, if I ask you in C#, if you create a button on the form, how do you make the button respond to an event?
Double click it.
Right. So when you double click it, it takes you behind the scene, right? And what does it do? Does it like gives you a plain page to write stuff?
It creates an event event handler.
Exactly. It creates an event handler for you. And in C#, it creates different event handlers for each object, right? So if you have 3 buttons, each button will have their own clicks. In Java, that's not the case. It doesn't automatically create event handlers, and all the buttons will share an event handler. And in that event handler, you will be able to differentiate between the buttons by their object names. So if this button is clicked, then do this. If this button is clicked, then do this. So those are some of the differences that you will see between coding in a Visual Studio environment versus coding in a Java environment. Okay. Now down below here, you see J checkbox, right? This is like a checkbox. And you see a J combo box, which is a drop-down box. We don't call it drop-down, we call it a combo box. And button group. Why do we need a button group? The button group is needed for radio buttons, because radio buttons by default, you can select all of them. So to create a group out of them so that you can only select one of them, you need to add the radio buttons to a group. And don't you do something similar in C# by going to the properties panel? So that if you have like collection of different radio buttons, you want like out of this collection, only one can be selected. Out of this collection, only one can be selected. Did you guys ever do anything like that?
No, we can put them in a group box.
Right, that's what it is. That's a button group. That's it. Yep. Okay. Now, I think I've gave you enough information to move on into the chapter. And as I told you, the AWT toolkit was the older one, Swing is the newer one. And then in advanced Java, we will learn about Java FX, which is the latest graphical user interface development environment of Java. And learning Java FX will become easier for you after you learn CSS. Because Java FX uses CSS for its presentation layer. You know, the colors and the fonts and the size and all of that stuff. It uses CSS for that. So that's why, you know, you will be seeing. So I know a lot of you are taking internet programming this semester, and those who are not taking internet programming this semester can take it in the summer, because we have internet programming in summer as well. Because this course and internet programming course, they're both are prerequisite to advanced Java. And that's the reason, because in advanced Java, first of all, initially when you go in Java FX, you will be seeing a lot of CSS there. And also when you move on to the enterprise side of the Java, you will be developing the server side application. So you need to bring the knowledge of your internet programming class to build a client side website, and then connect it to the server side website. And then that'll be your final project. So I know a lot of you are taking internet programming, love CSS.
Oh boy, do we.
No?
You know, I don't mind it truly. It's just kind of just another kind of thing to kind of get used to. But once you get the hang of it, it's not too bad. But
Love-hate relationship.
yeah.
So anyway, you'll be seeing internet programming in almost every semester after this one. So that stuff will be with you in the third semester. You will need that knowledge again in the fourth semester when we go into PHP programming, which is another server-side technology. So yeah. Okay. So the Swing classes are part of a more general set of GUI programming capabilities that are collectively called the JFC, Java Foundation Classes, okay? Now, I told you that Swing is lightweight and AWT was heavyweight. That's why we introduced the Swing environment. Now, another very important concept in Swing environment is that all the objects are actually children of component. So component is the word that is generally used for a graphical user interface object, okay? Now the components are usually placed in layout managers, which are containers, or frame, which is a container, or you will hear about one more thing, panel, which is also a container. Containers are special components that can hold other components. So that's something that you'll be looking at. Okay. Now, what do you understand from figure 14-1?
They're all children of the object class.
Right. And then notice that the parent and child do not have to be in the same package. Component is a child of object, but in a different package. Container is a child of component. Window is a child of container. Frame is a child of window. And J-frame is a child of frame. So that's why I said you cannot run away from AWT because Swing is based on AWT. If you have more than one constructors of a class, what do you call those constructors?
Overloaded.
Very good. Now that you understand what overloaded means, now these 4 bullet points will make sense to you. That's why I said earlier on that the first 12 chapters, you need to know them to understand any of the other chapters in Java. So now based on my need, I will call a constructor. Now, typically when you have a window has a title bar. The title bar shows a text, which is called the title of the frame or a window. If I want my frame to be titleless, I will call the constructor and pass no parameter. If I want my window to have a title, I will pass the parameter with some title to be displayed. Similarly, if I want a graphics configuration and I want some kind of a string, I could take that approach. So again, when you look at these 2 lines, the first line creates a J-frame with a title. The second line creates a J-frame object without a title. Now, if I were to take you into like writing this code in week 1, how many of you would have understood this? Or even week 2. So that's why it's important. Now, when you're looking at it, you're like, oh, okay, it's a class, it's an object. I'm allocating memory, I'm calling the constructor and passing the parameter. It just makes sense to you when you break it up like that. Because now that you have learned how we create objects, anytime you see something like this, you know exactly what's going on here. Okay, now when you look at these methods, what do the first 3 letters tell you for each one of these methods?
If it sets or gets,
If it starts with set, it is setting a property. If it starts with get, it is getting a property. Simple as that. Now, all you need to do is concentrate on, oh, okay, set title mean it'll set the title. Get title will get the title. Set size will set the size. And get size will get the size. Set size is overloaded. One takes 2 integer parameters and one takes an object of dimension type. Is everybody following what I'm trying to get to this here? As to, you know, once you understand the concepts, then reading the Java code becomes so much easier. Okay, now let's look at this guy. Okay, now when I look at the first line, public class JFrame1, okay, I have a class called JFrame1. Okay, now I'm importing a package, javax.swing. I need that package because I want to work with the graphical user interface programming in Java. So as a result, I have a frame object, which is coming from that package. That frame object will give me a little window with a title saying first frame. The size of this window will be 250 pixels by 100 pixels. So that's the width, that's the height. If you do not give the size in Java, the size of the window is 0. You have to set the size. Also, by default, the window is not visible, so you have to make it visible. So when you write this code and run it, what happens when you run the program creates a window on the screen of this size and makes it visible, and like this, just like that, you know, with nothing on it. Now, this look and feel will change over the period of time. For example, if you're using earlier versions of Java, you may be able to match with this, but the latest versions of Java may look a bit different than that. But the bottom line is you will see something similar to that. So what I would like you guys to do is open a new class and call it JFrame1, code this, and run it. So when you run this program, you will see something very similar to this one, right? Maybe slightly different, correct?
Yeah.
Now the thing is this, I want you to hit the X on it. Did you guys already hit the X on it when you were running it? Right?
Yep.
Okay, did that close the window?
Mine did, yeah.
Yeah, okay. However, if you look at the bottom right corner of your Eclipse, do you still see a big red square?
Yep.
Yep.
That means the application is still running. Closing the X only hides the window, but doesn't kills the application. Okay, so hit that X, hit that square, red square, so that the application actually gets done. Now, how do you actually terminate the application upon hitting the X? You have one more property to turn on, and that is called jframe.exitOnClose. Okay, now how do you code that is what we'll be looking at here. Okay, hold on a second. No, not this one. Okay, go do this for now. In your current example, I want you to add this line, the very first line. This will give you a different look and feel of your Java application. And the look and feel that you're getting because of that line is the look and feel of Java, not Windows. So if you go to Java's operating system, there's an operating system developed in Java called SunOS that was developed back in 1990s. And it would run on a hardware called SunSpark. So SunOS had this look and feel, has this look and feel. You see how X and the maximize and the minimize are different? So that's because of the set default look and feel decorated. Now, let me tell you a few more things. In Java environment, we don't call them maximize and minimize. In Java, if you're talking about SunOS, we call them iconified and de-iconified. Iconified means minimize, and de-iconified means you have opened it back up. Again, those are Java terminologies.
That just sounds purposely confusing.
Okay, this is the line I was talking about, guys. That set default close operation, jframe.exitOnClose, and that's exactly what closes it. Okay, so in your code over here, I want you to add this line at the bottom. A-frame dot, that's the name of your object, right? A-frame, right? A-frame, that's the name of your object of JFrame type. So right, type A-frame dot set default close operation. Do this within the main. And then in the parentheses, JFrame dot exit on close. Now that's a constant. And then you can tell by simply looking at it is all written in all caps. So once you write that line, then you run your application and hit the X on the window. Now the application will close and the red square will not be seen. Yeah, give me a green check when you have run it after that statement and can make sure that that square is not there anymore and it's closed. Okay, now I'm going to page 709. Label or J label is also something that you have seen in C#. It's a read-only text, right? So J label in Java is a child of J component, which is a child of container, which is a child of component, which is a child of object. So J label is a graphical user interface entity that you will see on the J frame. However, it is a visible entity. Okay. So now, if you look at this, what do you understand from these 6 bullet points? What are these?
Overloaded constructors.
Overloaded constructors, right? So you can see that if I leave it empty, then no text is passed as an initial text to my label. It'll be an empty label. I could display an image in my label. I could display an image and align it horizontally. I could pass a text. I could pass a text and image and alignment, or I could pass a text and an alignment. Those are my 6 choices. Okay, now in order for me to create a label, I create an object of label type, and I call the constructor and I pass something to it, which becomes the text of the label. Now, instantiating label on the frame is not enough. You have to make it part of the frame by calling the add function. So it's similar to you dragging and dropping an object onto your form in C#. That's what basically you're doing here by calling the object of the frame type and adding the label to it. Okay, so have a look at this code. In this code, we are setting the frame width and height through constants. You don't have to, but the author is just showing you different ways of doing things. Creating a frame with a label that says third frame, setting the size through constants, making it visible, making it closable, creating a label object and adding it to the frame. As a result, you will see something like this. So make necessary changes to your existing code to match this code. You could leave the current class name. You don't have to change it to JFrame3. And then make the necessary changes to achieve the output. And let me clear the feedbacks that you have given me so far, so you can give me the new feedbacks when you're done.
You want us to make the frame width and height constants as well? Or?
Yeah. Okay, everybody get to see the label displayed. And let's move on. In AWT package, we have a special class called font. The font class has a constructor that takes 3 parameters. It takes the font name as the first parameter. If you want to create a bold font, then you'll say font.bold. It's a constant in the font class, followed by the size of the font. Now you have 4 options of styling the text. I'll write in the chat. Font.bold is one way. Font.italic is the other way. Font.plain is the third way. If I want to create both font, bold, and italic, there is no constant to do that. You cannot make, there is no constant called font.bold italic. But what Java developers did, they created all these constants as numbers. So they ask you to do something like this, what I just typed in the chat, to create font, bold, and italic. Just pass the sum of the 2 integers. And when that is received as the middle parameter, it knows to apply both. Okay. Now, once you set a font, once you create a font, to assign a font to a label, you will call a setter. The name of the label dot set font, and then you will assign it a font object. You could do it that way, or you could create an unnamed font object right there and then. Either way, you will get the same results. Okay, so have a look at this. We're creating a new object, and then we are giving it a font name, a style, and a size. And here we are assigning the font to the following label. Okay, so how about you guys in your existing program make the necessary changes. Leave the same class name, add the font object, and assign the font object to the label. And let me clear the feedback so that you guys can give me the feedback when you're done. Now I noticed that I'm getting lesser feedbacks than what I was getting before the break. So is everybody not doing it?
No, doing it, just maybe getting a little tired. That's all.
Okay. Christian, are you back from your break? I didn't see any checks from you in some time. Anyway, on the same page, author gives us two more ways of creating objects. So he creates a headline font and assigns it some basic properties, and then uses the headline font to derive a font and gives that font a plain style, keeps the same Arial font, and reduces the size to 14. So that's how you can create another object. Okay, now comes layout managers. Layout managers are extremely important for you to place multiple items on your canvas. Now, in your current example, add one more label, greeting to, and add that greeting to label after the greeting label. Go ahead and do that. Just make these two lines, or add these two lines and run it.
Are we completing this figure 14 and 12, or is there something before this?
Are you not following with us the examples that we've been doing from last half an hour?
I wasn't able to, unfortunately.
Well, then, well, yeah, for you, then you would have to do everything that you see here.
Okay.
Yeah.
Is there other stuff?
Well, it's basically all the other examples that we did before are add-on. So this is how far we have come.
Okay. I got it. Thank you.
Aiden, yeah, who are you, right? But when you run this example, it will not show you hello. You will only see who are you. And the reason is, as I told you earlier, that at any given time, you can only display one object on the frame. So the second object overwrites the first object. And that's exactly where the layout managers come in. And that's why we need layout managers, because layout managers can hold multiple objects, and to the frame, it is like, oh, I'm still dealing with one object, which is my layout manager. So flow layout is one of the layouts that allow you to display items as they come in. Now with flow layout, if you do the default constructor, it just displays all the items in the center. You can do right align or you can do left align. That's your choice by calling those respective constructors. But you have to make sure that after you create your flow layout object, you assign that flow layout to the frame, so that now frame knows that whatever new objects come in, they will be part of a layout. So Christian, instead of doing 1412, you can continue with 1413, which is 1414, I mean, which is basically the same code with one additional line, okay? And that additional line is this line over here. You don't have to have a layout object to then assign the layout object. And again, this is something we have done in IO operations as well, that create an object on the fly if you only need it for one line. So all we need to do is introduce a layout to the frame. So the frame knows that there is a container that will hold all the objects that I will have. And all of a sudden you will be able to see both the labels on the same line. So that one line will do the trick. Okay. So now everybody should see both objects just like this. And now, Aiden, whatever you're expecting is what you will get now. Hello, who are you? Right? Okay, before we get to the next example, I just want to make sure that everybody gets done with this example. So, Jack Lear, are you done with this example? I know Jack, yours comes and goes. Right. Okay, so we're just waiting for Christian. Okay. Okay, now let's move on to the next one. Extending the J-frame. That means that instead of creating the J-frame objects in the main, you want to create your own class that will serve as a frame. And the benefit of that would be that once you create that class with whatever you want, you can then be able to create objects of that class, and you'll be able to create different windows. So as opposed to getting locked in one frame, you'll be able to create many frames that share the same properties. So we will, if you look at this one, this will remind you of chapter number 10, that you're creating a class called JMyFrame as a child of JFrame. You are setting the width and the height to be the properties of the class at the instance level, constants at the instance level. And then you're creating a constructor. The constructor is calling super. What is super? The parent constructor, and setting the title of the frame. And then notice, since you are already in the constructor, you don't have to do a frame.setSize. Because you're already in the constructor means whichever object calls this constructor, all the setters will work on behalf of that object. In the previous example, you were creating the object in the main. That's why you have to call the setters by the object. Now, in the constructor, you're already calling it with an object, so it will work on behalf of that object. So these setters do not need any reference. As a result, when you're done with this, then look at this example where we are creating an outside main method outside in a different class. We're creating two objects of my frame type, and each one of them will generate a frame on the screen. Okay, so now create this one, figure 1416. When you're done with that, create 1417 as a separate file and run 1417, and you should be able to see this output.
So on that one, is it extending JFrame 1 or what? I see it says there JFrame.
Yeah, because JFrame is a built-in class. So we are creating our class as a child of the Java's built-in class,
Oh, I
JFrame.
see. Yeah, I should have imported it. Oh, that's
Yeah,
my bad.
so, yeah.
Sorry.
Now, the author of the book, she uses this approach, which is not preferred by Java developers. You don't import the entire package if you only need one class.
What would you do?
You just import that class that you need, the approach that we have been taking all along, that we only import one class that we need, javax.swing.jframe. Like, you know.
Okay, yeah. That's what it automatically did for me.
The automatic approach of Eclipse is the preferred way versus this one.
Okay.
Yeah, this is lazy approach.
So what was the result we were supposed to get from this one?
You will see when you run this one, not this one, the one with the main, you got to run figure 417 because 416 you cannot run because there is no main, and you will get 2 frames.
I only have 1 frame.
It may be overlapping the other one. Did you create did you create 2 objects?
Yeah, I have J frame 6 and then J my frame.
Right. So did you try moving, because they may be overlapping each other?
Is it okay if I share my screen?
Yes.
Okay.
Did you code figure 417? 1417? Yeah, right?
Yeah, they are. They were overlapping.
Oh yeah, that's what I said. You know, they
We
must
just
be
hadn't
overlapping.
refreshed. Yeah.
Yeah. Okay, cool.
Thank you.
Mhm. Okay, having said that, adding JText field and JButton to JFrame. So JText field is a text box. That's what it is. Text box. So JText field is a child of JText component, which is non-visual text box, which is a child of J component, which is a child of container, which is a child of component, and which is a child of object. So JText field has one constructor that lets you set the size of the JText field in the number of characters, approximate character size, and then your JText field will be that wide. It doesn't mean you can only enter 10 characters. You can enter more, but at any given time, you will only be able to see 10. And then you can add it to the frame as long as you have the layout manager, and it'll show you wherever you add it. So the sequence of adding is important in the sequence of visibility. So similarly, if you want to change the text inside the text box, you will say response, the name of the text box, because that's what the name of the text box is in this example, dot set text. It will put that text inside the text box. If you want to retrieve a value out of the text box, you will say response dot get text, like here. Okay, it will then retrieve the value and will return it into your local string object. Just like you will treat your regular setters and getters in your regular class, that's exactly how you will treat this as well. Okay, so, okay. Then comes JButton. JButtons are buttons which could be created with nothing, with an image, with a text in an image, and some kind of action. Okay, so those are some of the options available to you in JButton. JButton is a child of abstract button, which is a child of J component, and the list goes exactly the same as before. In order for you to create a button, you create a constructor, you call the constructor, you give it a text, that text appears on the button. And then if you ever want to change the text on the button later on in the code, you can simply say the button name dot set text. So as you've been seeing this pattern, it doesn't matter if it's a label or it's a button or it's a text box. If you want to change the text, you call set text. If you want to retrieve the text, you call get text. So it's the same idea that you see across the board because they all have the same parent. Okay, so you can return the text of the button and you can store it in a string object. No difference. Okay, now have a look at this example. This is the same example that you've been working with. Now that in this example, we're adding a text box and a button. And the place where we add it is the place where it shows. Okay, so we add the button and the text box in the sequence where we first add the text box and the button, is the same sequence it will show. Okay, so now make necessary changes to this example, and then you may have to code the component demo, and that will be your output. Okay, so whatever you call this class, if you want your previous one to be saved as, because the previous one we worked on was not this one, the one that we worked on it before that. So this is the example 14. What is that? 1414? Yeah, 1414 example is what the author is working with now. Again. So you may want to save it as, if you want to save it as JFrame with many components, change the class, change the constructor name, and then make the changes. Once you're done with making the changes with 1421, then you code 1422 and run it to see the output. Okay.
So for this one, are we creating a new one or working on the old one?
As I said, you open that one, you save it as,
Okay, got it. Got it. Thank you.
and then you make the necessary changes. And this will be the new name that you will save it as. Once you are done creating this one, then you will create a brand new class called component demo where you will run it to demonstrate the output.
And which one do we run for this one? To display it?
Figure 1422, which is right below figure 21, because that's the one that has the main.
Gotcha.
So a couple people not done yet, still working on it.
Yeah, I'm still working on it.
Okay. Cole, did it fix, or did you rejoin, or you're still in the process of going out and coming back? Oh, okay.
So I'm getting an error on mine, and I'm not sure what it is.
Okay, let's have a look at it then.
It's not completely finished yet, but I
Oh,
can.
then first finish it and then we'll
Yeah.
have it, guys. Okay.
Where's the code again?
Page 721.
Yeah. Figure 1421 and 1422.
So is it all right if I see 1421, please? Thank you.
You still have errors, Christian?
Yeah, I just finished it, and I still have a few errors.
Okay, let's have a look at the code. I mean, there was only 2-3 lines to add to the existing code. I hope you did not rewrite everything. Okay. You know what? I must share my screen again. Okay. Christian, have you ever written a method inside a method?
Yeah.
You have?
Wait, no, I haven't.
Why?
It doesn't work.
Exactly. And that's what you did. You wrote
A
everything
method
in the
inside of a
main.
method. Yeah.
So, I've been telling everybody in all the second semester classes, before you call me, it's about time you guys start analyzing your code, because most of the time it's a very simple mistake that you
I have
can
a
fix
lot more
yourself.
errors now.
Yeah, that you can fix yourself. And it's like you have the solution in front of you and you're just simply copying the solution. So it's very easy for you to tally back and forth. Now think about it, if you were to write your own solution, which you guys do in your homeworks. So this will help you.
Oh, that's why. Yeah. There are quite a few more errors here. Which is, oh wait, hold on.
Okay, did that fix all the errors in this code?
Almost. There, I guess I was just missing a few stuff, a few things.
Okay. I don't think so. There are so many lines to add. There were only like 3-4 lines you had to add.
Yeah. I rewrote it thinking that it was a whole new thing.
That's what I've been thinking, that you must have rewritten everything, because that wasn't that much work.
Yeah. Is it right if I share my screen?
Well, I can only let you share your screen once per problem.
Okay.
I'm just kidding. Go ahead. Christian, really? Did you go line by line for real? Now, I am not helping you. You got to fix it yourself. I will just share the screen with you and you figure it out. Because that kind of mistake, first semester, week 2, 3, I will help, but not after week 2 or 3 in the first semester. You're ending second semester.
Oh, you're joking.
Remember, you're copying the code that's already written for you. So you got to be more careful. You guys should be able to identify the problems by looking at it. So that's basically what I want you to be doing. That's why I'm getting hard on you guys. We're still making first semester mistakes. You're not in first semester anymore. And third semester, I'll be even tougher. Because I got to prepare you guys for industry. I'm not preparing you to go to middle school. Done?
Yeah.
Okay. So create a new class.
All right.
And that's the code that goes there. You're creating an object of the first class and you're making your frame visible so that whatever is on in the frame constructor can be seen on the screen. You done now?
Yeah.
Okay. So guys, what happened here was that we created an object of JFrame type, which called a constructor. When the constructor was called, in the constructor, we said the title of the frame demonstrating many components that goes as the title. Since the width of the frame is smaller than the length of the title, that's why the title did not display it entirely. Then what we did, we set the size for the frame, 300, 150. Those are the two constants. We made the frame closable. We declared a heading, JLabel heading. We set the font for that. And instead of creating an outside object, we create on the fly object. We created another label called name prompt, in which we put the text, enter your name. And then we created a text field called name field, set to the size 12. And then we created a button called button, and it had the text click to continue. We set the layout for the frame because if the frame's layout is not set, you cannot add more than one component. And the order in which we add the components is the order in which the components show. So we add the heading label first, then the regular label, then the text box, and then the button. Okay, now we set the size of the label such that things nicely display. But if I increase the width of the frame, then you will see that all the items may show up on the same line if it's wide enough, or maybe on 2 lines. So that's the problem with JFrame. With the flow layout, you have to make sure the size is controlled. The next important concept, which we'll not have a chance to work on today, but I want to briefly talk about it, is event-driven programming. That when you are done coding your initial look and feel, the next step would be to work with events. And when you're working with events, what exactly is happening is that you want to notify the user that when you perform an action, I'm ready to respond. So that's the event handling part of the Java programming. So in order for you to do the event handling in Java, your button needs to tell the Java that I'm ready to handle the events. As a result, your button needs to call a method called addActionListener this. This means when you click as a user, the reference of the click goes to the button. So the button is telling, I'm ready to receive an action. Once you do that, you need to then be able to work with the action perform method. That's a method that will respond to the click event. Where does this method comes from? Special interfaces called event handling interfaces. Remember in chapter number 11, you learn about interfaces. Since your class is already a child of JFrame, it cannot be child of event handlers. Therefore, all the event handlers across the Java are written in interfaces. So you implement an interface which lets you code the abstract method if action performed. And that handles your events. Now look at this code here, okay? So now, first of all, we need to add action listener. When we add the action listener, we need to incorporate awt.event package action listener interface. As a result, you will be required to code action perform. That's an abstract method. You have to code that, okay? Now, your button needs to tell the Java that I am capable of responding to an action. As a result, when you click on me, I will respond. So when somebody clicks on it, it automatically forwards the request to action performed. An action performed receives the request in a built-in object action event E, which is capturing the event that happened. Now, that means when the button was clicked, action performed was called because button said I am capable of listening. Inside the body of action perform, you simply grab the text from answer, which is your text field, in a string called name. You concatenate it with that with another string called hello, and then you set the text for greeting, which is your label, okay? And here you are running as a demo. So this is basically what your program will look like. You have a frame in which you put a name of a person, you click press me. The moment you hit press me, that name is grabbed, concatenated with the word hello, and it shows on the frame. That's what basically the program does. Simple event handling program. This program has one error. Okay, where is that error? Can somebody tell me in a minute?
Is it the J label? The L is supposed to be capitalized?
Very good, very good. On line number 5, J labels L should be uppercase. That's a typo. It should match. The class name and the constructor name must match. Okay. So this is what basically this program does. This will be our starting point for next week. Next week, our main focus throughout the class duration would be to work with the event handling part of Java, Swing environment. And of course, we will go outside the book and we will then incorporate objects. Once you understand the basics of it, then we can bring in more tools, more objects that are not discussed in this one chapter in the book. Because the idea of this one chapter in the book is only to introduce you to the basics. And from there on, if you notice in the chapter, after we are done with this topic, there's only one more topic left in this chapter, and the chapter will be done, where the author quickly introduces you to checkboxes, button groups, and combo box, and that's it. But then we have to put it all together with other things that we will bring in the next class. Okay, so any questions before I have one more item to tell you?
Do they ever make a GUI to do all this like they do in Visual Basic?
There are tools out there, of course. Eclipse also has a third-party tool that you can build a drag and drop environment. But again, you will then be tool dependent. That's why you can always pick up on the tools. I'm just trying to give you the basic understanding of what goes behind the scene.
I get it. I was just curious.
Yeah, there are tools out there. Some are paid, some are licensed, some are open source. Yeah, absolutely. Okay, so this week, if you are looking at this week's button, you will see that spans 2 weeks. It is 405 through 419, right? And the two chapters are chapters 13 and 14. We completed 13. We're almost done with 14, but we have to do a lot more practice with 14. There's no new quiz or new assignment for you guys.
April Fools? Huh?
If I did that like 5 days ago, it would make sense, but not on the April 5th, right?
Yeah.
Thank you.
Yeah, for real. Thank you.
No problem. But at the same time, can you guys please go over chapter number 14 so that next time when we are in class, you guys, are up to speed with it, so that I don't have to go over these little things with you, because I want to do some examples. Okay? That's
Absolutely.
all. Yep, that's all I'm asking. Just go over chapter 14. Even the two topics that we didn't go over in class, we'll still go over those. But then after we cover those topics, we're going to start working on the examples. Okay?
Alrighty.
Cool. I'll see some of you tomorrow and some of you next week, and have a good one.
Have a good night.
You too.
Night.
Bye.
Have a good
Good night.
week.
You too.
See you next week.
Okay, anything from me, from either of you, either of Jack or Christian?
Nope. Have a good night.
Thank you. Jack, you okay?